Welcome to the Software Lifecycle Stories podcast. We bring you stories of what worked and sometimes what did not in the course of discovering, designing, developing, delivering, and using software-based solutions, as shared by practitioners who went through these situations. Anupama talks about efficient algorithms, about writing efficiently versus writing fast, the skills an architect needs, and also the differences in architecting large versus small applications. And finally, tips for women who need to or want to take a break in their career. Listen on. Hi, Anupama. Good to talk to you after a long time. Welcome to the show.
Thanks, Shiv. Same here. It's been nice catching up with you.
Yeah, actually, I have a lot of questions for you, but then we'll go as per the usual format. That is with you introducing yourself, and based on that, whatever comes up. And as I mentioned, it's a freewheeling conversation. There is nothing right or wrong. It is all about your experiences and what our listeners can learn from that.
If I were to introduce myself with a one-liner, I would like to call myself a passionate programmer and, of course, a problem solver. That's how I think of myself. Having said that, I've been working in the software industry for the past 25 years. I started my career as a programmer way back in 1992. Graduated just after graduation out of college, and have been working with various organizations with different domain focus. Initially, I was involved with a group of companies which was breweries, distilleries, and we were in-group software wing of the company group, and I was working there as a programmer. And later on, I moved to an offshore setup in India, where product offshoring was popular during those days. And so we were providing developer support on internet forums, early days of internet. And I was working as a developer there, and then moved on to a services product company where I worked for long 13, 14 years, where I have held multiple roles from a junior programmer to a product architect, working on various domains and services, product architecture and storage and e-commerce. Then I took a break from regular full-time employment and started working as a freelancer, and got together with a few other women of similar profile, and we as a group started taking up projects and delivering projects to small startups and small companies. I did this for about 4 or 5 years, and then again got back onto mainstream corporate job, wherein I was involved with a company which delivered a product in health tech space. So I was with this in the health tech domain till about 3 months ago, and currently on a break, just stepping back to think what I want to do next. I've been on the other side. I will also handle responsibilities of leading teams, delivering projects, coordinating with customers, and all the works as a engineering manager, senior engineering manager with these companies. It's been a very interesting, exciting journey, especially for the fact that I have got exposure to various different domains in manufacturing, customer service, services, tech services, storage, health tech. And it's been very fascinating to learn and to contribute in very many of these roles. That's what has kept me ticking and wanting to do more.
Yeah, wonderful. I think congratulations on 25 years. So as an architect, that is the first question that I have for you, is that in terms of technologies, today there seem to be too many elements or components of technologies, particularly if you are putting together an architecture. How have you seen the evolution of, let's say, architecting a large system maybe 15 years ago to today? What are maybe some additional complexities that you've had to deal with?
You're right. If I were to recount on how architecting as a practice started for me. So my first tryst with an architectural challenge, I would say, if I think back, was in my very first job when I just had finished my probation with my first job. I was assigned with a project that I had to develop materials requirement planner for a brewery distillery. And being a young developer out of college, the biggest thing in my mind, and when I say material requirement planning, what it involved was basically the distillery or the brewery would come out with a plan, yearly plan, their production plan of how much liquor would they be selling for the coming year. And that had to be broken down into inventory items that are required to meet that production plan. And being the young developer, I just took it head on. For me, it was a challenge it was a tree explosion in my mind in terms of algorithm that I had to get right. Okay, and I was very excited to have cracked the algorithm and how to get it all right, and it was all working. And I kind of finished it in probably half the budgeted time, and I went back to my senior manager and I told her, I'm done. Can you just take a look at it and let me know if I'm on the right track? And she was a very senior person, and she actually gave me a smile and said, yeah, let me check. And then she checked and she said, perfect, you've got your algorithm right. Can you just run it with with the actual data? I can get you the actual production plan from one of the companies, and you please run it with that and then see how the outcome is. And I started doing this, and the whole thing started running and would never end. And wow. I realized that now I didn't know what to do, because I didn't know whether I was looping infinitely somewhere that it didn't stop, or was there something else that was happening. And then I went back to her and said, this is happening, what do I do? So she said, I think your algorithm is right. There is nothing. It's just that it's inefficient, maybe. It's just taking too long to do what it's supposed to do. So just leave it overnight. Let's time it and see how much does it take. Okay. So that's when I would say, I would think of, if I think back, that would be my first problem in architecture, where I had coded up everything, and then I had to now relook at everything that I had done to say, whether I have to scrap this and redo this. Okay, but then luckily for me, with some help from my senior colleagues at that time, I could kind of tweak my algorithm and say that, okay, we bring down the performance time for this particular run. And what took about 10-15 hours to run a small production plant. This was a very small distillery in the entire set of distilleries that we were rolling this out for. And then we had to bring it down to 15 minutes, and we did it. And that is when I actually first time I realized that requirements, what looks on paper is very different from what the requirements should be considered from the point of view of a developer. That was my first. And going on that way, what I realized is that till about 2000 or late 1998, around that time, there was really no formalism of software architecture. It was as much widespread in the product development life cycle. Every developer ought to be thinking about all architectural requirements or considerations. And also, it was not really something that once people decided what operating system, what platform, and what programming language, there wasn't much a separate thought invested in software architecture as such. People used to typically handle it depending on the challenges that they saw in the implementation of a particular project or a particular problem solution. But towards 1998 is when I remember when I first used any formal method of architecture. And in those days, it was quite popular and was known as a 4+1 model view of architecture. That was pretty much very early ones, at least in my experience. I would think of that as a successor to the ever popular UML thing that was people were using in design, in software design. UML was pretty much a software design tool, and people started seeing a lot of gaps in those formalisms or in methodologies and tools, and they started asking question, how do I represent the UML diagram or in the UML methodology? And then people probably woke up to the fact that there are things that cannot fit into design or UML, and therefore probably this requires something different. And the 4+1 model that I have used was still just a representational model rather than a software architecture as a practice. So this is the first exposure to software architecture model at that time. And later on, when internet became ubiquitous, there were a lot of things in the software component that had to be rethought because of, now the client server architecture was passé, and people were moving into the web application models, and a lot of things that worked one way in the client server world wouldn't work in the web world, and rethink how to do these things. Say, for example, HTTP sessions, stateless sessions, and session maintenance were costly in the web model. All these things became real concerns when we tried to build, distribute, and run applications on the remote internet nodes. So what happened was there were in parallel a lot of things that emerged. On one hand, the application architectures were being layered, what we know today as multi-layered architecture. Early days of those, this was around 1999, 2000 time when, and then there were a lot of focus put on transaction management. We used to have dedicated servers for transaction management. And how do we handle the latency between HTTP sessions vis-a-vis the database to query performance. So a lot of these things came to the fore, and people start inventing solutions in a lot of these little pockets, and new paradigms emerged. And that is when probably around what I remember is around 2000 when I first attended one of the developer events by Microsoft, is when for the first time I heard one of the speakers put together a total complete definition of what software architecture is all about. Until then, it was always a big debate about is design architecture or are some parts of design is considered as architecture, or is architecture nothing but high level design, right? All these raging debates were happening, but very formal definitions of what software architecture is and what software architecture practice is, what should an architect do, all these were not very clear. It only emerged once the web technologies became very popular and widely used. That is when the architecture definitions started to emerge more clearly. So people at that point understood architecture as something that caters to all your non-functional requirements of an application. That was a very a concise definition of a very complex concept, I would say. So when that happened, a lot of things moved forward very fast. Now people knew what was considered architecture. Now people started focusing that as a separate practice where you needed somebody in the team who would look at architecture, architectural considerations for an application separately, work on it, and build these requirements, get a buy-in from the customer on non-functional requirements, educate them about non-functional requirements, and then build that into the design, and then percolate it down to code, and then probably review it back, review the code back to see whether all the architectural considerations that were designed have been met in the code. All this started happening slowly around that, and that is when architecture became a formal methodology or practice. And being that was the beginning of the definition and how we started implementing architectures as a separate step in the application development. A lot of tools were not available. Okay, I mean, in the sense, there were very few tools. There was not so much standardization. Like any other thing that is emerging, right? There are not many tools to support what you wanted to do. And so pretty much everything that you did had to be homegrown. Okay, I remember one of the projects that I worked on. This was early days. It was a very early e-commerce project that I worked on in the year 2000, and so probably first version of what we can see in Flipkart today in those days. And one of the biggest thing that we faced, biggest problem or challenge that we faced in in that project was that suddenly product they launched a discount scheme or a a festival bonanza kind of a thing for the customers. And there was a surge and spike in the traffic to the site. The number of users hitting the site spiked 10 times when they announced the scheme. So the product, the application which was running so smoothly hitherto, kind of started failing and would go down once in a while after the number of users hit the site. And we realized on analysis that there was actually a memory leak and a stack overflow that was happening because of a particular memory leak that was happening in the application. And to solve that problem, I remember that we had to sit through profile the application, sat in the data center of the product where it was hosted, and then we actually profiled the application with the profiler that was available. So profiler was pretty much the only tool that was available for us, and we profiled and saw where the memory was getting consumed and what was leaking. And it was about 3 days of effort to even analyze and find out what was going wrong. And then after knowing what was going wrong, we had in the self-referencing table in the database, and we had to redo that particular piece of the logic, and that took us another 3-4 days. Okay, while we were able to manage the customers' load by provisioning alternate servers and stuff like that, but it still took us so much time to turn around because mainly of lack of tools. If you compare to what is available today. Today, you could possibly run a profiler as it is happening and catch what is happening, where is the overflow or the memory hog happening in probably 10-15 minutes if you watch the profiling tools available today. So the only profiling tool was a database profiling tool in those days. So a lot of architects' work used to be in the trenches, that you had to dive down deep into the code and into few tools that are available and manage all your architectural elements and their functioning correctly. That was the challenge of the architecting job in the early years. Vis-a-vis, if we compare what happens today, in a similar situation that happened probably recently with one of the products that I was working on, your approach is very different. So when we found that the self-referencing table was causing a problem, we had to write a really our own solution to a self-referencing table, and we had to spread it out, make it flat, build our own little using temporary tables, and that's how we solved the problem then. But today, that's not how we go about it. If you know that particular query is intensive, memory intensive, or processing intensive, I know that there is a caching server that I can add on, slap it on top of my application server, and I just reroute my query results to the cache, and I am done. Probably I can get the fix done in a day, especially if your application is cloud hosted and you are using the cloud infrastructure services and cloud based services for your application server, caching server, all of them are available. So typically the architect's job is kind of one used to be like that of a mechanic who knew every nut and bolt machine and would get under the car to do everything required to build and to maintain the car earlier on. Now it has become something that you ought to be more aware and knowledgeable and intelligent about various tools that are available for you. It's become pretty much a kind of assembling of tools. Okay, so it's pretty much that today. So the shift in the job for the architect is that rather than it's still the knowledge of what can cause a query to take more time is still indispensable. You need to be able to say that these kinds of queries are expensive and this kind of algorithm is bad, and those basics have not changed. You need to be able to analyze and put your finger on the architectural issues in the application right up front and through the life of it. But in addition to that, you also need to be much more knowledgeable about what other things are available which you can gather and assemble and provide solution in the quickest time. That is the additional thing that you have to be able to do today. Okay,
Wonderful.
without that, even with best of knowledge of what is the problem or what problem needs to be solved, tools will we can leverage to attain those solutions. It will be very difficult to give cost-effective, acceptable solutions to customers because of their own exposure to plethora of technologies, like you rightly said. Customers are also more demanding today. Okay, when you go back to them saying that here is my big architecture where I will give you everything homemade and handmade, they would immediately question you, why do you want to do that? Okay, it's more expensive today to do that. So that's the shift. Today it's become more expensive. Do everything all by yourself, and you would rather do it with a plethora of other tools that are available to you, assemble them together to give the most effective and efficient solution. But other than that, I would say the basic elements of in terms of computer science as to what makes a good architecture, that hasn't been, that there is mostly no change. Okay, while newer paradigms have got added to it, and as and when new tools have come up, we would also be able to relate our fundamental knowledge to the tool. If I know that there is a caching server, there is a container, I should be able to relate to what's problem, what solution, and what tool. That mapping has to be clear in an architect's mind today. And I would say architect needs to be on the lookout for all the tools that are emerging. And that's the shift.
Yeah, that's very interesting, Anupama, that you said that there are so many new technologies and it is becoming more of assembling, but at the same time, knowing what all is available, what are the limitations and so on. And you kind of preempted a question that I had in terms of what is that one key skill that an architect today needs, which I understood as being aware of what is available and then how can we quickly put something together. So there are two questions that came to my mind after that. Now, do you see a difference in an architecture for, let's say, a small organization versus a large enterprise? That is part A. And part B of that is when you take these architectural decisions, particularly in the startup space where you have done a lot of work, and you look at something like this lean startup or this fail early, fail fast, all those concepts, where your architecture also, you expect it to be cheap. So what is the dilemma that an architect faces, and then how have you addressed that? How do you take decisions when some things are ambiguous?
One of the things with this one that you asked about small and large enterprises, of course, there is a lot of in the way the customers' demands are in these two spaces. Okay, before even looking at what will be the architecture that is of relevance to these two type of organizations, type of applications, I would look at from the customer perspective. These are two different things. Right. The smaller ones typically drive you towards minimization of cost, ease of use, okay, low cost of maintenance. These are typically the requirements from the smaller enterprises, because they don't want to invest heavily, or they don't have the required skills to maintain the applications through its lifetime. The technical skill set required and all that are not available to them. And being small, they are very cost conscious. The large enterprises are typically less worried about cost, while that is changing right now. But they're less cost conscious, but they have other requirements, pretty much very higher order requirements in terms of security, privacy of data, confidentiality, availability, which are, of course, the other big difference is the user profile of the two different types of organization. The smaller organization typically involve users, especially skilled, or it's a small set of users who are using your application, and they do it day in and day out, and they are the ones who are using it through the years. So there is that is the scenario in the small organization space. In the enterprise world, their users are ever changing. There's a large set of users, and therefore the requirements are varying. What works for one user does not work for another user. And the training levels, skill levels are all different. And therefore, it's very difficult to have one solution fit the entire set of users. Those are the two set of challenges that exist. Okay, but with what has happened with cloud becoming ubiquitous, irrespective of whether you're a small organization or large enterprise, both want to leverage the cloud technology for their applications. Maybe for different motivations and different reasons, but both nevertheless want to go on cloud. The large enterprises typically still, the mindset is to have a private cloud, whereas the smaller enterprises are more open to publicly shared cloud hosted services. So that's been the demand and the differences in the two spaces. So that brings a different dimension of a challenge for the architecture of applications, especially if you are a product which caters to the entire spectrum of organizations, from small to large. Okay. Earlier, it was possible if I knew that my customer was a small organization, I could have a light version of my application, really. In the sense, my architectural considerations were catered to their requirements, and I would build an application keeping in mind their constraints as well. So they had hardware limitations, they had whatever other limitations they had. I would tune the application capabilities also to their environment and to their needs. And for a large organization, similarly, we would do it keeping their requirements in mind. We would have probably a different version or a different flavor of the product. Okay. Today, with cloud technologies emerging, while the basic requirements are segregated, like I said, okay, people also want to have a movement in terms of what is offered in the product. So let's say a small organization starts out saying that I don't want any, my application does not have heavy traffic. It has very limited number of users. I want limited availability, whatever. And then they might start out like that. But as they grow, because of their awareness and availability of cloud services, they will move up the chain and say, can you add these as well to me? I want to integrate with a third-party vendor. Can you give me integration services? Now, I want to do, work with a large enterprise, and therefore, can you scale the application to so many users? So it has given room for smaller organizations to seamlessly scale their businesses themselves. And therefore, they have the requirement to scale the application as well along with their business. So they really upfront look for an application which will work for their small scale operations as well as a scaled out operation. So that becomes a fundamental requirement for them now. So there isn't much that maintaining multiple flavors of the application with support for different architectural requirements will become a nightmare for the software vendor. And therefore, more and more softwares are evolving in such a way that you have a single architecture which caters to the breadth required by a small as well as large enterprises. It also is advantageous to the software vendor in that your same product could be serviced to a small organization as well as your large enterprises. So your market breadth also increases alongside as a software vendor. So that is where the architecture is moving towards. Today, it's hardly you will find anyone who will architect specifically for small organizations and large enterprises. But the challenge that is now there is that earlier we could make a trade-off. Because we said the hardware limitations are there, I would do a certain set of things in my application so that it doesn't impact me. So we could actually, the constraints and the trade-offs could be worked out better when we were catering to small and large enterprises separately. But today, that's not the case. We have to make sure that both constraints and trade-offs have to be worked through the scheme of whatever architecture that you're proposing so that it works for both. That is the biggest challenge, right? So say, for example, in a large organization, right, they would say that I do not want to put out my application out there on the internet without appropriate client-side verification and validation. So you need to have client credentials embedded into your browsers or whatever. And these clients are users are spread all across the globe. Now, when you come to a small organization, probably with limited set of users in the same location that it is hosted, these people would say, I don't want the extra maintenance of maintaining client-side credentials or client certificates or whatever mechanism of security that we propose. So it becomes a problem for them, whereas the other one is a requirement. So this is the challenge that the architect will have. So in all cases, we have to think about how to solve the problem for a small guy as well as the big brother. So you have to come up with solutions that work in both spaces seamlessly, and that's a big challenge. It's not doable as first step in most applications. because architecture, all decisions, then probably that leads into your second question, saying, how do you go about making these decisions? Typically, architectural decisions are never either right or wrong. For a given situation, you look at the constraints that you have, architectural constraints, and the architectural trade-offs. And you actually discuss it out, saying that if you are not willing to invest a lot in processing power, then you should be able to live with slightly lower performance levels. Or you factor the application in such a way there are only small pieces which are high performant and others can be performing low because your processing power is limited. So architects are always used to making decisions like this, saying what is a constraint that I'm working against, and for that constraint, what is a trade-off I will make elsewhere. And you take a consent from the customer, get a buy-in and his understanding of the situation, and then proceed with making your decisions. Okay, whether you have caching. So if somebody says, I want a higher performing application bit, then I have an option to either say, can you put a caching server, extra server for caching? I could do that, right? If the customer is willing, and then my architecture will look different because I'll have to now provide for a caching server. So this is how typically the architectural decisions are made. But today, because of this, blurring lines as to the requirements of a small enterprise versus large enterprise, one, the lines are blurring because of their requirements of seamless scaling. The other reason is also services themselves are now externalized, unstandardized. Say, for example, earlier, the small organization would have its own hardware limitations or data center limitations. Today, they don't have any limitations when they go to an infrastructure vendor, services vendor. So they are on the same level playing field as any other large enterprise. They have access to all the load balancing servers, all the caching servers, everything that could impact your architecture. What is available to a large enterprise is also available to a small guy, and in a toned down cost, because there is a pay-per-use model ubiquitously available. Now, without incurring huge cost of an additional server, people can afford and buy an extra load balancer for their application. So because of this, there is an expectation also to be done this way, where a single architecture should work for both. And there is also availability of services at all different service levels, so you can afford it as well. So because of this, the decision making is becoming difficult, because now there are no clear-cut constraints, there are no clear-cut trade-offs, and it's even much harder to negotiate this with the customer upfront. So therefore, you always have to, the challenge in the current software architecture practice is to actually cater to all your constraints without so much room on the trade-offs. Okay, so that way it has become so much stricter. The job has become more difficult. Okay, but one thing that kind of helps that cause, I would say, is the availability of these tools. Okay, so if I can make my application session stateless, okay, then it would be much easier for me to deploy it on a single node for a small organization, which just requires few users to be using the application. Whereas I can scale the same application using a load balancer provided by the cloud provider. And therefore, I don't have to do so much to actually, the effort wise, there is much less to do. In earlier case, I would not only think through the two solutions, but also take the responsibility for implementing those two solutions. Today, implementation is pretty much provided. Therefore, the decision is still very important. The decision to catch the right decision, saying, if I have to run this application on a single node versus 100 nodes, okay, what is it, one piece in the application that I have to focus on? How do I replicate my sessions? And that is a upfront thinking that you have to do and make the right decision to keep the architecture open so that you make the right decisions in your application design, so that it doesn't limit you to either the small application space or to the large enterprise space. So that is the challenge, and that is the also the tools available make it convenient, provided you put the focus on the right problem to solve. Okay, so the problem to solve has shifted. What is the problem that you have to solve? Earlier, you had to solve it in two spaces. Today, you have to solve it for one seamless spectrum. And therefore, your decision-making points are different. What decisions you make are different today.
Yeah, thanks, Anupama. That is a very clear explanation of one of these questions that I always had. Actually, this triggers more questions, but we are running out of time for this episode. A couple of things that I do want to talk to you about, particularly the breaks that you said you took, the first break and now again on a break, and also helping other women. I think it's probably, it merits another episode by itself. So I would like to catch you again soon, to have a conversation on those topics.
Sure. Yeah. Those are topics closer to my heart as much as software architecture is. So
yeah, so as a teaser for what might come in.
Yeah.
So as a teaser for what we may talk about, is there any one tip that you have for particularly women who take a break and who want to come back in? How can they keep in touch with what's happening, with so many changes happening, so that when they come back, they don't feel completely lost? Maybe a short answer, so that we'll do the detailing in the next episode.
Yeah. I would say there are few things that women can do. First and foremost, I would say you shouldn't be afraid of taking a break. Let me also add that I have been extremely fortunate to have employers and companies that I worked with who supported me through my endeavor of doing this. Okay, I have extremely good bosses, I should say, who supported me in this. But even otherwise, I would say that you got to make up your mind that taking a break is okay. Even if you look at a career which is going across 25 years without a break, okay, you will go through multiple changes or transformations in the work that you do. It's never the same, right? And even whether you are willing to do the transform or not, whether you are willing to move from one to another, the technology space itself is so fast moving that the movement is imperative. It's not possible to avoid it. And therefore, in fact, if you look at it, if I have taken a break for about 3 years, let's say, what would actually you would be losing is that on the boundaries of the 3 years, you may not be able to connect those two. But typically, there would have been a plethora of technologies which has come and gone in between. Okay, so therefore, it may not impact you very directly. That many times there isn't really a total continuity between everything that you are doing. There are always shifts, and therefore, if you skip one block in between, it should not really matter. Okay, so that's the second one to take heart from. And the third thing is, while you're taking a break, just be aware of what is happening in the world, even if you're not doing anything about it. Okay, one of the things that I used to do is there are a lot of these conferences, there are a lot of these events that are organized by startups or typically available for a small fee or even free things that happen in around town, and make it a point to attend those so that you don't feel lost when you are there, and take up any small thing that you could take up. There may not be so much of a monetary benefit that comes from it, or it may not be of a level that you would want to contribute at. So if you're an architect, you might actually be asked to do something. Somebody might want some help in setting up a website or setting up a particular small tool that they want to build. Okay, so it's important to feel interested and be on anything that is related to your technology and things like that. So you may not really get the job that you would otherwise do in a corporate, but even at a task at a lower level is very, very good to keep doing, so that you can get whatever knowledge or the linkage that you are looking for will be there. And the other one I would think is it works a lot better if you can collect few more people like you working away alone during that period. One, it'll collectively you will still have knowledge, productivity, time, everything available, and they also enable you to deliver bigger things than you would otherwise as an individual. And it works beautifully when many women are taking a break for a similar reason. Most women take break for maternity causes, I would say. So if there are other women with the same reason, it really works very well to have a group and do something together. You learn together, you do together, and you shouldn't feel any jerks when you start back again. And I would definitely say the one break that I took earlier has given me confidence to take a second one right now. So it should be easier. Once you get into it, people would really appreciate how that works out.
Yeah. Thanks, Anupama, for sharing your experience. I'm sure there may be questions from our listeners too. If we get something, we will pass it on to you.
Sure, Chef. I enjoyed it as much as talking about it. Thank you.
Thanks a lot. If you like the show and would like to share your experiences with the community, or know someone else who might want to do that, please get in touch with us at podcast@pm-powerconsulting.com. That is podcast@pm-powerconsulting.com.
Please rate the show on Podchaser, Stitcher, iTunes, or any other podcast client that you find us on. Please also share our episodes with your friends and others in your network. If you or anyone you know would like to be featured on our show, do write to us at this email address: podcasts@pm-powerconsulting.com.